This is an example of the application of the epsilon delta definition of a limit. So first, recall the definition of the limit of a function. We say that the limit of f of x as x approaches a is equal to L if this condition is satisfied. We have to show that the limit of x squared as x approaches 2 is equal to 4. So for this case, our a is 2 and L is 4. So we have to find a delta such that for any arbitrary epsilon, this condition is satisfied. Let's label this condition star for easy reference later when we need it. So again, the condition means that we need to show that f of x, the absolute value of f of x minus 4 is less than epsilon. We need to pick a value for delta that implies this. So let's look at the graph of x squared. It's a parabola that opens upward with a vertex at the origin. And let's locate x equals 2 and y equals 4. And we also pick an epsilon. It's an arbitrary value. You don't have to pick an exact value. Let it be arbitrary. So suppose we have this for our epsilon. Our epsilon creates the interval 4 minus epsilon to 4 plus epsilon. And then we locate the points corresponding to this on the graph. So 4 minus epsilon has a point on the graph with coordinates x sub 1, 4 minus epsilon. Similarly, 4 plus epsilon has a point on the graph with coordinates x sub 2, 4 plus epsilon. So like just what we did in the previous example, we look for delta from epsilon because we need the delta to imply the epsilon condition. So it's like we're doing things backwards. So let's solve for x sub 1 and x sub 2 to express them in terms of epsilon. So for this case, we get x sub 1 equals square root of 4 minus epsilon. X sub 2, on the other hand, gives us the value of square root of 4 plus epsilon. So we are reminded of the interval involving delta. So for this case, the widest interval that we can have is the interval from x sub 1 to x sub 2. Because if we have an interval that extends to the left beyond x sub 1, for example, if this is our interval, if you try to extend this to estimate the points, so if we pick, for example, if our delta creates an interval, let's say this is this is 2 minus delta to 2 plus delta. So we can pick a value of x here, and if you observe, the corresponding y value of x would be outside the interval involving epsilon. So I hope it is clear to see that indeed the widest interval that we can have is the interval from x sub 1 to x sub 2. So we will pick a delta that is the minimum distance between 2 and x sub 1 or 2 and x sub 2. Okay? So we take delta to be 2 minus x sub 1 or x sub 2 minus 2. Okay. So this means the delta must be less than this, and it should also be less than this, since it's the minimum. Less than or equal to, you can say less than or equal to. Now, this was the condition that we found. These are the conditions that delta needs to satisfy. Now look at this. If we multiply the inequality by a negative sign, we reverse the inequality symbol. So this gives us negative delta is greater than the negation of this entity, or the negation of 2 minus square root of 4 minus epsilon. Now, if we recall, this inequality implies this inequality. When we remove the absolute value, we get an inequality that is equal to this. Negative delta less than x minus 2 less than delta. Now, negative delta is greater than negative of the negation of the expression 2 minus square root of 4 minus epsilon. So, we lay it down here. Also, delta is less than square root of 4 plus epsilon minus 2. So, we put it down there. Okay? So, now, we simplify using algebra. Now, what do we observe? We just ignored delta. There's nothing wrong with that since we're still following the rules of inequality. And then we apply some basic algebra laws to arrive at this. Now, we can square both sides, and this gives us this inequality. Now, we can transpose 4 or we can subtract 4 to every term in the inequality, giving us x squared minus 4 between negative epsilon and epsilon. Now, this corresponds to an absolute value inequality, which is the absolute value of x squared minus 4 is less than epsilon. So we can say that therefore the limit of x squared minus 4 is as x approaches 2 is equal to 4. What does this tell us? This tells us that the the delta that we found led us to this. Hence, we can conclude this.